he asked me what the Ivory power here in this title means. And I'm not sure how many of you follow the Scala mailing list or the Scala IRC channel, and there's this, it's like kind of the clash of the titans. On one side you have the enterprise, which is doing like real work, and on the other side you have academia, which sits in its ivory tower and does all these pretty things, but nobody can use them. And I think that's a false dichotomy, and there's really no such thing as a bridge, as a gap between enterprise and academia. And academia invents interesting concepts, and with a little bit of library support, they can be used in real world work. And so this title is kind of a little bit of an inside joke on this eternal war between those two worlds. But, yeah. And I'm hoping that I can show you some things how to make your life easier. And the thing is that Scala set provides many concepts which you have already invented but didn't know that they have a name, and that they exist maybe in a more general form than what we have invented. And I'm not going to talk about monads or some other stuff today. There, I said it. But yeah, mostly about some random things I picked from Scala set, and I'm not going to talk about theory. I'm going to give you some code demos, so expect that at some point there might be an exception on the screen because it's a demo, so it's live and stuff can happen. And also I'd like this to be very interactive, so because I have very few slides, only like 10 or 15 or something like that, please, if there's a punchline which you don't get, or if you'd like to know something more, or just like what happens if you type that stuff, just shout it and I'm typing it and we can see what happens. And I hope that I can give you an ad hoc explanation if such a thing occurs. Yeah, so who of you has already heard of the Scala set library? Who of you uses it already in production? That's good, and the rest of you should raise your hand like next month. Yeah. So a little bit about me. I'm a maintainer of Scala set. So I'm actually at this point I'm not the main author anymore because there are other people who do much more actual code work in Scala set. But I'm the person who reviews all the pull requests and does the release stuff and things like that. And initially I planned to talk also about Scala set concurrent, but I just decided to not talk about that because Marcus gave a great talk about Akka, and I cannot possibly add anything you didn't already hear today in the talk, so I skipped. What I'm going to talk about is error handling, what we do in the Scala set. So in Akka you have this thing let it crash, and then you have the supervisor, and you kind of expect crashes, but that's really a good model if you do program in the large. But if you do program in the small, you probably don't want to expect crashes everywhere. So that's the first thing here is I'm going to elaborate a little bit on error handling with Scala set. So in Java, the compiler cares about checked or unchecked exceptions. So who of you has already seen a signature which has throws exception in there? Probably some of you, and you all love it, right? So yeah, throws exception is awesome because you always have to write this try catch block or rethrow stuff, and you have no idea what's going to happen. The compiler complains about that, and you have exceptions all the way down until you reach tuples, and that's bad. But the thing is, the JVM doesn't care at all. So that's just a compiler flag. And if you program Scala, or if you learn Scala, you might have thought, yeah, well, there's no throws keyword or something like that. How can the JVM possibly know? It doesn't have to know. It's just a hint for the compiler, but otherwise Scala just ignores it and doesn't care about check runs and checked exceptions. And I'm going to argue that checked exceptions are actually a mistake and can be broken down to a more fundamental concept. Yeah.
I think the Java guys regret it. In Gothic, I think it was.
So I told you that the JVM doesn't care at all about exceptions, and I'm going to demonstrate that. What? Okay, let's do this. So this is really an interesting piece of code, because it demonstrates that you can also in Java throw stuff which is not checked by the compiler. Just have a look at that.
I've seen this before. It's an X text. It's an X
Really?
Text. It's called sneaky throw. And it throws checked exceptions in an unchecked way. I've seen exactly this before, yes, and I thought I don't see right.
So what happens here is kind of an ugly hack which exploits type erasure, because what happens here is that you have this rethrow method, and it takes any exception. It doesn't care about this exception at all. It says, okay, I'm calling this unchecked throw instead of, and this has this t extend throwable, and it kind of says, okay, I'm going to tell you that it's a runtime exception, so you don't have to handle it. I'm going to tell you it's an unchecked exception, but here you do a cast, and normally you would expect that this fails with a class cast exception, because you have an IO exception, you're trying to cast it to runtime exception, but the thing is that in Java, those types are erased, so at runtime there's only object, and this cast actually succeeds, and I'm going to show you that it actually works. By running this example, so yeah, it throws my own exception, and yeah, that's really awesome, isn't it? Yeah, and it was already indicated, Scala doesn't care at all about exceptions, so you don't have to write a try catch or whatever. So if we just try some Java method which throws something. We just write like integer.parseInt to, yeah, it just gets thrown, and we don't have to write a try catch or anything around that. Okay, so if you have been following the discussions about lambdas in Java, which might or might not arrive in Java 8, they will?
They will
Really? Awesome.
It's already feature complete, and you can download it.
Cool. So I think some 2 years ago there was this discussion what to do about introducing a general function type. Because as soon as you add lambdas to a language, you have to ask yourself what's the type of a lambda. And now it's a different approach, but previously they thought of adding such an interface where it says, okay, I have a general function which takes a t, returns an r, and throws something. Because like Java has checked exceptions, and you cannot just throw anything in lambda, because you have to make sure that this is in the signature. And really, this throwable thing here is actually part of the signature in Java. So in a general function interface, you would need to put this e as a type argument here. And here's the thing. What really happens is that r and e are two possible outcomes of this function. So either the function returns normally and gives you back an r, or it throws an exception and gives you back an e. So that's really what happens. It's not like you have you have two exit points of this function. One exit point gives you an r, and the other exit point gives you an e. So we can also say that it returns either r or e, right? So we can just boil it down to one exit point and say, well, it can return either that or that. And this really simplifies our stuff, because we don't have to care about this weird signature thing, because it's not actually a return type, it's completely disparate. And if you're interested, you can read up about that, because Java actually supports pattern matching. You can do some weird stuff with that. Just Google Java exception pattern matching, and you can, like, exceptions are completely bonkers in Java, because they have some weird language features which are not available everywhere, but I digress. So, yeah. What we really would like to do is have a function which doesn't throw, but returns either a success state or a failure state. Okay, now let's write that. We define a function which is save parseInt, and it takes a string. And now we are going to do the following thing, which is say integer.parseInt, and we try to parse that. And yeah, let's see if it's a number format exception. We want to return some sensible error message. So for example, you would say, okay, string is not a valid integer. So now here's a little problem. The stuff returns any, so which is the Scala equivalent of object. So that's not very useful because now you have to do some weird pattern matching to get, or some type casing to get out whatever you want to do. But luckily, Scala is covered and it has a type called either. And either is a type which has precisely two states, a left state and a right state. And the mnemonic for that is the right state is the right state, so it has a success, it's right. Yeah? You could also call it success or failure, and you will see that Scala will actually call it that way. But yeah, it's a convention from many functional languages. And what we can just do here is we can just wrap our result into right, because yeah, it's right, and we can wrap our error message into left. Okay, now what the problem here is that Scala does a weird signature, but you can ignore that. You just say Scala uses either, and it's either a string, which is the error message, or an int, which is the result. And now you can define that function once in your code base, and now you can call it save first int with like 3, and you get correct 3, or if you call it with something else, then you get a left. So now here's the thing, you cannot just get a value out of there, so you cannot just extract the integer out of that object because it could be as well an error message. So what you can do is you can compose it and say, okay, I have multiple of those either objects and do some operations on them and give me a new either object. So for example, if you have an input form from a user, and the user has to enter 2 numbers, and you can parse it and then add them together or whatever. And this looks like the following. So you can say x out of save first int. Let's say let's do a correct one first. And now here's a little quirk which Scala has with the Scala standard library. So you have to tell the compiler which one is the error type, because by default it just assumes that neither of them could be, so both could be the error. So you would, by writing .left, you say, okay, left is my error type. But that's not too important here. Now take something else, and then you can say, okay, if both are correct, just give me the sum of both. And you will see it is correct. That's not cool. Okay, let's just ignore that. And I'm going to, I don't know, it's the Scala standard library. It sometimes does weird stuff. I'm going to just tell you what happens when you have a failure.
So getting the right?
Yeah, we should get the right is in.
We're not interested in errors.
We're just adding 2 strings.
Yeah.
Not left, not right.
Sorry?
You either has int on the right side, not on the left, not on the left.
I could try it with right. That's right. Yeah. Okay. Yeah, sorry about that. So you were right after all. Okay, so let's look at what happens if you have an error somewhere in there. Say you have food. Okay, so you will get the error message, which will be bubbled down to your expression. So if some of those things fails here in this for loop, it's not actually a loop, it's for comprehension, and it bubbles down your error right until you can see it here. And it's yeah.
Could you specify that we want to use the plus here on integer, because as we saw before, we can do plus on strings, so we got the strange result before. Can you specify that you want plus or integers?
Unfortunately not. So in Scala you can, the plus operator is like you can smash anything together and it's all strings. In order to do that you had to define your own add function which only takes integers, and then you would have gotten type error. But unfortunately the plus operator is kind of, it's inherited from Java, where you can just add everything to a string or a string to everything, and Scala also does it, which is kind of a design mistake. So.
There's no int dot plus?
Sorry?
There is no int dot plus?
No. I mean there is, but the type of integer dot plus is really, it takes any, and if it's not an integer it converts it to string. Alright. More demo. Okay, what you already kind of expect is that what happens when you have two errors. So normally you would think it would be cool if you got both error messages, because really if you have a form validation and you user types two wrong answers and you just like validate it and you say, well, your first answer is wrong, and the user corrects the first answer and say, well, your second answer is also wrong. That's not really good user experience. And what happens with the standard here is that actually you only get the first error message. That's not really a good thing. So now we are going to switch to Scalaz validation, because the standard library just doesn't support that kind of thing. And for that, there's this library called Scalaz contrib, which brings some predefined validators, and we can have a look at them. One of them, for example, is a validator for integers. We can call it, its name is just int, and we can do it like just expected, and you already see that now the thing is called failure and not left.
Is this a Scala set failure in Scala 2.10?
It's Scala set failure.
Not the.
And if you plug something valid in, then you see it's not right, it's success. So that's way easier to understand your code if you don't have this anonymous left and right. Success and failure. Now what we want to do is we just as you can see, we already have to supply the error message every time. So we just write a nice function which does that for us. Just going to call it save parse int again, and it just says okay, not a valid number. So that's just like previously. Now we can call that just like expected. So nothing interesting happens here. So now let's turn on the magic. Assume you have a list of strings and you want to convert them all to integers, and you want to get a list of all error messages if like 2 of them or 3 of them are not valid. But if all of them are valid, you would just like to get the complete list of integers, right? Problem clear? Let's start with an easy example. And now we just say does that work? Yeah, we get a success. Everything is well in there. And now let's put in one failure. Oh no, one failure. And now let's put in 2 failures. Failures. So there's something a little bit wrong here, because you can already see that it just took the error messages and plugged them together, just like with string concatenation, which is usually not what we want to do. What we want to do is we only want a list of error messages, so we are just going to tell that to our save parse in function. So let's recall our save parse in function. and we just say, okay, give me a list. Yeah? So not a plain string, but a list of string. And now, if we say again this and that, now you get a list of error messages. Now you have a list, not a valid number bar and not a valid number foo, and you can present that to the user and everyone is happy.
Can I sit in the position where the error occurred? Which element is this error used?
You can do that, but not with this function, and I'm going to, yeah. So you might wonder what this traverse U function was all about. So that's really the magic sauce. It's like the most awesome function in Scala set ever, because it can turn anything into everything else. No, I'm just kidding, obviously. So what it does is it takes something which is a collection, for example, like lists, and looks inside this list. And this list can contain options or validation or whatever, and it turns it inside out. So for example, if you have a list of values, and some of them might be null, and you call traverse on them, it just turns it into a list of non-null values, or it gives you null if either one of them is null. So it turns it inside out. It tries to give you it tries to pull out the nulls to the outside. And here you don't have nulls in there, but you have success and failure. And what it tries to pull the failures and successes out. So what you get is in the end a plain, so you give it a dirty list with some successes and failures in it, and it tries to give you a clean list with all successes, or if it doesn't succeed in doing so, it gives you all the failures it encountered.
Is it a way to get it, say, a list with two lists, one with the one that was converted successfully, with all the correct integers, and another list with all the failures?
Yeah, you can do that, but this function is called unzip, and I don't have a card for that, so I'm going to have to look it up. But there's also a function which does that. So. And the U is really a thing for the type checker, because the Scala type checker does some, yeah, it's not as smart as you might think. So if you remove that U, it gives you some weird type error. And the U is some hack which does some guessing in the background and tries to estimate what you are after. And don't worry, this guessing is totally safe, so it cannot produce any exceptions or stuff like that. And yeah, it's also type safe, so no worries. You just call traverse U, and you'll be happy.
It's a feature of the compiler.
It's a feature of the Scala set library.
Oh.
And just I'm just going to show you that this actually works for other stuff too. So let's just assume we don't want any error messages, but just options, so some or none. Then we can define our save parsing function a little bit differently. Let's do it that way without error messages. So we can just say some or none. You can also do that, so you can say traverse U with this modified save person, and now we don't get success or failure, but now we just get options.
Does this also work with Scala neutral success and failure?
Yeah. So you can have almost anything in there, and it tries to turn it inside out. So that's really a useful function. Okay, any questions so far? Are you still with me?
You showed a for comprehension for Ada, and also showed for the validation.
Yeah, that also works. Show you. Just let me redefine that thing. So now you don't have to do that left or right shenanigans, because you have the success and failure, and it always knows what is the failure. Good stuff. But now the question is, what happens if you have two failures in that for comprehension? Just say that. Now you really have just one error message, and this is a problem because, it's not really a problem, it's conceptually so, because in the for comprehension, the second statement could depend on the first statement. So you could have, like here, you could use the X. And if this already fails, the compiler has no way to continue to that. There are some corner cases also that happens with futures. You sometimes get unexpected results. If you have some futures in your for comprehension, then sometimes the second future doesn't get run in parallel because it could depend on the value of the first future. So sometimes the for comprehension is really not the best thing what you want to do. If you have stuff which depends on each other, that's cool. But if you really have stuff which can be executed in parallel or validated in parallel, you should always use this list thing and traverse your stuff.
The future in for comprehension, you can define the future outside the for comprehension.
Yeah.
And can run in parallel if they do not depend on each other.
Yeah. So, but that doesn't happen with validation because there's no such thing as running validation in parallel.
I'm not familiar with Scala syntax. Is it this for comprehension something like do syntax sugar in
It's
Haskell?
exactly the same. Exactly.
So I'm struggling for several days now of combining what you said, futures, which are monads, and also this either or validation classes. This can you give a simple example for how to do this? I've read about transformers, monad transformers.
You don't need monad transformers to do anything. So if you don't want to use any of this for comprehension, so if you have some parallels, some stuff which doesn't depend on each other and you want to validate it, or
No, it's all dependent on each other, but it uses always future of the return type, so it's always encapsulated because we use filter.
yeah.
And we also have not the simple return type, but we have a future of either or future of validation.
Okay, well,
And
right. Then you need to do transformers, but I'm afraid that's a little
Okay.
bit complicated
Yeah,
for
I will ask
example.
later.
We can talk
Yeah,
afterwards.
thank you.
So it's really not that difficult, but
Yeah.
it's a little difficult to get right if I'm just
Yeah.
doing it live. Okay, so I'm going to skip that stuff because there's concurrency. Okay, yeah, still have a little bit of time, so I can just give you another concept without any further explanation. Nexus. So you all love Java beans, right?
No.
Did anybody of you already use JSF? And then you love it, right? So you have getters and setters everywhere. You're just like awesome. And yeah, that's a Java bean, right? So there's no constructor, but just imagine a constructor or let it generate by Eclipse or whatever. And if you want to update something deep down in a hierarchy of stuff, with Java beans it's really easy because you just start in your root object and you get the IT department and you get the head of the IT department and you set the name. So that's really cool because it's really it's not much boilerplate. You just write it that way, and the problem is that you obviously have a mutable state over here. So you mutate your objects, and so just a short digression. Some people say that the real world is mutable, but that's wrong. If you believe that the real world is mutable, try changing what you wrote yesterday. So the real world is really just a function of time to some state. So the real world is not mutable because you cannot change what happened earlier. So with mutable state like that, you forget what happened previously, but with immutable state, you can always keep a copy of what happened earlier. So that's really, in a nutshell, why immutable state is bad. Now in Scala, it's a little bit different. All of you probably know case classes. So you can just have very few boilerplate and have everything generated for you, accessors and equals and hash code and toString. And you don't even have to tell Eclipse to generate it for you because you get it for free from the compiler. And yeah, that's like the same thing as 2 slides earlier from Java, but now you have a problem if we want to update the head of the IT department, the name of the head of the IT department in our company. And we could do it that way. But yeah, so the case classes, they get a copy method. So you can say, copy my case class with an updated value. But now you have to do this copying all the way down, because now you can say, well, I want an updated company with an updated IT department, with an updated head, and an updated name. So that's horrible. And you don't want to do that. And if you do that in real world code, your colleagues will murder you. And that's really not something we would like to do. But luckily, there's an advanced Haskell technology for that. By the way, anybody who has a Twitter account and doesn't follow PLT Warrock is really doing a great mistake. There are a couple of those accounts like PLT Warrock or PLT Hal. They're really awesome. Yeah, so what's this fancy thing? Co-monad, co-algebra. I'm not going to tell you that. You can Google for it and read some papers about it. The thing is really called lenses. And you can imagine a lens like a focus on a data structure. So you have a large thing, like a company, and in this large thing you have a small thing, like an IT department. And the lens is just saying, okay, I have a focus on this IT department, and I can get this focus, or I can update this focus and return a new thing. But it's really not that interesting. And let's just have a look at some code. So you have this, just ignore what's in these objects here. You have this company and department and person, just like I showed you in the slides. And I also already defined these lenses. You have to do that one time. One time you have to write a little bit of boilerplate, but then you can use it everywhere. So what is company.it? Normally you would say you would access, so company is just the default object of that with some department. And normally you would access the IT department with company.it and the person, the head with that. And I'm kind of inverting that now. A lens is just an accessor. So you have an accessor called company.it, and you pass it to company and it gives the IT department back. And that's really what this thing is. It's an accessor, it looks for a department in the company. And now you can call get on it, and it gives you the IT department. So that's not really interesting. It's the same thing we've done before. It's the same as if we are calling company.it. So now you're wondering, why is that ever useful? What can I do with that? Now, here's the interesting thing, what happens. You can compose these things. So recall we have this accessor for IT in a company, and we also have the accessor for the head in the department. And now you can see that now this thing and this thing is default. You can kind of compose it, or you can you want to compose it, right? You want to compose it. And there's an operator for that. Some people call it a fish operator. So, and now we have some really weird type in here, and what happens is that now we have an accessor which looks for a person in the company. And if you hate symbolic identifiers, you can always have an alphanumeric identifier, and this is called and then. So you can read that as access the IT department in the company, and then access the head of the department. All right, let's give that a name. And now we can say IT head get company, and we get the person, which is nested inside. And we could also have done it with using company.it.add. But what's really interesting is that we can now use these things to set stuff. So what we can do now is we can say IT-head.set take the object, and now we give it a new person, and we call this person Ada Lovelace. And now we get an updated company, which has Ada Lovelace set in here.
It's a new version of the company.
Yeah,
The
old
old
version is
new one.
still there.
Okay.
So what the benefit here is that you get basically the same thing with Java beans, with setters and getters, just immutable. Because now you have not only fields, but you have kind of accessors for those fields, which you can combine together. And that's what the lens is about. So you have a big thing. Imagine this as follows: you have a huge book, and you have and it's really written in some really small letters. And then you take a big lens to get all those letters, and then you see, well, there's a footnote in there, but it's even too small. And you take another lens and put it on top, and then you can read the footnote. And that's really what happens here. So you can, so you this company.it. It's your big lens, which shows you the IT department inside the company, and then you can use the small lens to read the person in your department. And then you can compose those things together, and you can update your inner stuff. So that's really all that's about it.
In the end, you have two different objects then.
Yeah. And you can always write that inline. So now we're going back, and we're going to try to update what we initially want. We can say company.it, and inside there, the department head, and inside there, the name of the person. Now we can say set, and that's it. Now we have an updated company with somewhere deep in there an updated.
So this is basically syntactic sugar or the copy method on the base version?
It's not. It's like the copy method, but at the moment you have to type in those lenses manually. But that's not really difficult. There are examples all over the place. But there are compiler plugins which generate that stuff automatically for you. So if you want to look for that, you can Google for a thing called Willet. You can just put it in your SVG file, and you get all those things for free. So it even looks like this. You can write exactly that thing.
Can you show the type of this whole set of fishes?
You mean that one?
Exactly. Thank you.
So a lens family is really something which could return something with a different type, but that's not really important. So you notice that those two things are always the same type, and you can just disregard this duplication.
But it won't only work with case classes, I could also implement the lens, for example, on a database set, if I want versioning in a database.
For sure. There's another interesting lens, for example, maps. Maps give a really interesting lens because you can get the value according to a key, and you can also update the value according to a key, right? That's really an interesting lens.
Then we get a new map, a reference.
Yeah, you get a new map also.
But this is similar to like the persistent data structure.
Yeah. So lenses give you kind of an universal view into immutable data structures. Alright, I've already took way too long, and I hope it got clear for you. And obviously this is not code which you can start to type in and it works, but I hope that I could kind of whet your appetite. And there's an IRC channel, it's called #Scala set on Freenode. You can join, and there's also a mailing list, and just Google for it and you will find tons of help. There's also a manual called Learning Scala Set. You can just Google for Learning Scala Set. It's really awesome. It's kind of a step-by-step introduction. It's very terse, so it expects you to read on stuff you don't understand, but it kind of gives you a start on the syntax. Okay, that's it.